Let's take a look at another SAT question. We can see that this question has a table in it. And our first instinct might be to go ahead into Desmos and add the table, right? Which you can do. And then you just go ahead and you put in your X value is -11 and your Y value is 21, -10, 18, -9, 15, and -8, 12. Now, as soon as we have enough values, Desmos offers us the option of adding a regression right here. Boom. So we put in a regression, and we can see if we zoom in, we can't really see the points, but you can see this matches these points precisely. So there is our line that we need. And the question says, what is the x-intercept? When we're finding the x-intercept, we know that y has to be equal to 0. So the x-intercept is going to be here, -4, 0. So we solved this question. We answered this question by using Desmos. Okay, that's one way to do it. But then there's another way, which is kind of like the staring and pondering way. Let's talk about that a little bit. All right, so we'll get rid of this. And you can see we have these two sets of values. And x is increasing by 1, by 1, by 1. And y is decreasing by 3 each time. Okay. So you can see we go from 21 to 18 to 15 to 12. All right. Well, we need to get down to y, or f of x, being equal to 0. Well, we go from 18 to 15 to 12. We're going to need to go to 9, 6, 3, and then finally 0. 9, 6, 3, and 0. So we got to move up 4 more spots on the table. Well, if we have to move up by 4 more spots on the table, then this number up here, this x value, is going to need to increase by 4 units. So that's another way to sort of get at the essence of this question conceptually instead of relying on Desmos. Just stare at it. See if you can figure it out. It is possible to gain a concept and sort of walk your way through the table values without creating a table in Desmos. I mean, you can create the table in Desmos as well and then use the regression function to derive the line, but you can also just stare at it and use your common sense. I know that might be mind-blowing for anyone out there who is thinking, God, I hate math, I'll never be good at math, all those typical negative thoughts that we have about math. But I think that math's bark is worse than its bite. In other words, math seems to be much more complex and much more, esoteric and hard to understand and hard to, really parse than it actually is when you get down into the details of it. So anyway, hope that's inspiring a little bit. Let's move on to another question. Here we have a function problem, and we're told that f of 3x is equal to x minus 6. What is f of 6? Well, what we know from these types of questions is that 6 has to be equal to whatever is in the parentheses in the initial function definition. So 3x has to be equal to 6, which means that x must be equal to 2. Note, I'm not using Desmos to graph anything. I'm just using it kind of as a scratch pad here. So if we figured out that if they're giving us f of 6, x must be 2, then we just go ahead and plug 2 into this equation that they give us. 2 minus 6 is equal to -4, and that's the correct answer. So the secret to these types of functional relationship questions is whatever they give you in the question part, whatever's in the parentheses has to be equal to whatever's in the parentheses in the function definition. So in this case, we knew that 3x must be equal to 6, therefore x is 2. Plug it in, 2 minus 6, there you get, and that's how you get the correct answer, which is -4. All right, very good. Let's look at another one. These are so fun. All right, here we're looking at another SAT question. This one gives us a very simple relationship, which is just I is equal to V over R. Then it gives us some values to put in there, right? So we have 6n in the numerator, and in the denominator we have 500, right? And we know that the maximum that this can be is 0.25. Cannot be greater than 0.25, right? Well, this is just a standard fraction. You can go ahead and, just start solving things here. Oh, you know what else we can do? Wait, let's use Desmos to solve it. Tilde. And 1, boom. There, it solved it. Okay, I don't know if you know this trick, but anytime you have an equation with just one variable, you can ask Desmos to solve it by changing the variable name from n to n1, whatever variable name it is, letter followed by the number 1, and then change the equal sign to a tilde. So pretty cool. But anyway, we can do that and just immediately figure out that n has to be, in this case, for it to be 0.25, which is the maximum, then you'll need 20.83 packs of 6-volt batteries. And since you can't have a fractional pack of 6-volt batteries, you know that n must be equal to 20. But let's take a look at a different way of figuring this out other than just using Desmos's solving ability, right? So let's go back and look at this. Let's see if we as human beings can do this. I mean, you've got 0.25 times 500. Well, 0.25 times 400 is 100. So 0.25 times 500 is 125. So 6n is equal to 125. Well, that's the maximum that it can be. And that, as we've seen, is going to give us a fractional number of batteries. So you can't have a fractional number of batteries. So the closest multiple of 6 that's less than 125 is 120. So if we say 6n equals 120, right, now you're going to get a whole number of batteries, and it means that n will be equal to 120 divided by 6, which is equal to 20. And we found it by recognizing the fact that 0.25 is the maximum value that the amperes can be, and we need to find the largest whole number less than that maximum in order to find the correct answer, because you can't have fractions of a battery. Very good. All right, let's take a look at another one. All right, here we're looking at another SAT question. This one gives us 2 different inequalities. Let's go ahead and type these right into Desmos. Y is greater than 2x minus 1. You can see lovely green area showing us which parts of the graph fulfill this equation. And then we have 2x is greater than 5. So now you can see this overlapping area where the purple and the green overlap. That is going to be the set of all of the numbers that fulfill both of these equations. So what do we know about all of these points? Which of the following consists of the y-coordinates of all of the points? Well, we can see that all of the y-coordinates of all of these points in this infinitely large region all have to be bigger than that point of intersection there, right? Which Desmos helpfully puts a gray dot on, so we can just mouse over it and it'll pick up on it. So you can see that point, and I can click on it and then boom, do that. That is the point of intersection between these two graphs, right? And we know that that point is at the bottom of this region, which means that every single point in this region has to have a y value that is greater than the y value of this point. So that means that the correct answer to this question is B. That's the one thing we know about all of the y values of all of the points that satisfy both of these equations simultaneously. Cool. So hope you got a lot out of that, and I'm going to go ahead and post some more of these just because I'm so fascinated with how incredibly powerful Desmos is when you use it on appropriate questions on the SAT.